Is this circuit diagram just theoretical or can it work in real world? Let's find out. To start, we need to gather components. A battery for input, the 555 timer IC, a custom pulse transformer, and our rectification stage consisting of diode, resistance and capacitor. Finally, we have the heart of project, SCR, load and battery. First, prepare the timer IC. I am bending the pin and tinning with the shoulder for a solid connections. Now follow the diagram closely as we solder the components. Here you can use any microcontroller and Arduino also. Now we need a 15 ohm resistance, but since I didn't have one on hand, I used a 200 ohm resistance in parallel to obtain 15 ohm. This goes between the third pin of IC and base pin of transistor. Now for the complicated part, the pulse transformer. I am using same gauge wire for both sides. I use single strand for the primary but double it for secondary to handle more current. Wind the winding on case, add a ferromagnetic ferrite core and secure everything tightly with tape. Initially when I connected the power supply, the voltage fluctuated because of the 2N quad 2 transistor, so I replaced it with D8823 amp power transistor, which solved the stability issue. Now connect all the component of filter section as given in the diagram. Here look closely at the SCR. When the pulse triggers it, it turns on. But if I release the signal and it turns off, that is not true property of an SCR. If your load is too small, like a simple LED, the SCR doesn't reach its latching current. In this state, it behaves like a BJT, only staying on while the signal is present. To show you the actual latching property, I am switching to a high amp motor load. Now even when the gate current is gone, the SCR stay latched.